Greetings! In this video, we'll see how Blazor WebAssembly project can be given similar development experience as Blazor server for data communication. For this demonstration, I will create a project using .NET New Blazor WASM with a hosted flag. Also give it force right away to allow it to update the solution file. This .NET template starts us off with a client UI, this one, hosted on the same public directory as a server project, just that the source code is organized into independent project. So if we actually start the server project, run it, we get the Blazor WebAssembly UI. If we open up Pages, Fetch Data Razor page, we see that they both work on the same data structure where the forecast. The client uses it to view and request the data, and the server is using it to create an instance of it to send over the wire. That's why this project is called shared. Same data structure for both server and the WebAssembly client. A step that is commonly thought as required when working with Blazor WebAssembly is creation of an API, such as this one. This involves inventing various URL routes. In Fetch Data page we see one of them, but in larger project we have something as massive as this for every command and query. And then having a UI direct correctly to those URL parameters, so this page has to know exactly which controller route to go to. Then we have to create a route for each of those endpoints, and all these controllers are doing are just reinterpreting the parameters of the URL to create the exact same command and queries that the UI has created and sent over the wire. This awkward translation may be necessary if we are working with different languages on server and client, but it's completely redundant if we are able to compile the same C# library in this starting example shared on both server and browser WebAssembly. We just have to come up with an automated encoding and decoding process of the shared library to transfer over the HTTP. And MediatR pipeline easily solves this. So I'm going to start with just that, installing MediatR to all the projects. Now let's look at service controller action. This code can be extracted into its own query. You will do this most likely for real projects anyway, because it's not nice to have this much logic code in your action controllers. This query is going to be a common object, as it's going to be instantiated on a client and handled and executed by the server. This solution template already created a shared project that has libraries compiled into both client and server, so we're going to continue using it. Thinking of a name for what we're actually trying to request here, it is a forecast query. To emphasize that it is indeed a query and that MediatR is going to have to process it, it has to be extending iRequest. For the generic parameter type, we put in the output type that we expect to get. In this case, we have a collection of weather forecasts. If our query has additional filters, we can add them to a constructor. For example, if we wanted a forecast query for a particular date, we can put that into its constructor. That way, the query handler will read this off to give forecast for a specific date. Sample data given by the template does not have such filters, so we will leave this without a constructor. Server will be the one processing these queries, so I'm going to make a folder for handlers. We'll call this forecast query handler. And to link this query handler with the query, we extend from iRequest handler interface, or implement it rather. For the first type parameter, we specify what type of query that this is going to respond to. This is going to be a forecast query. And second parameter, we put again the type of response that we're expecting. We want, once again, a collection of weather forecasts. Once IDE implements the required function by the interface, we can move into it the actual logic code from the controller. We'll let it import all the needed classes, and there were some other variables that it was using, so we'll move them all into the handler. MediatR handlers tend to be asynchronous, especially useful because most likely you're going to be hitting external sources like databases, so we mark it as async. We have to let MediatR know where to find handlers for our queries and commands. We do that at startup, and here we need to do services.add_mediator, but it's not going to be available until we install MediatR dependency injection extension. Give it to the server. It will also be necessary in a client in the future, so I'm going to install it for client one time as well. And now add_mediator becomes available. I have to let it know where in which assembly to find the handlers. The easiest way to do this is to pick at least one class in the directory and get the assembly name using that. So we can say type of forecast query handler or get type info.assembly. This is by no means a complete RPC solution just yet, but I want to incrementally test how well this works. So I will add MediatR as an extra dependency to the controller temporarily. And I will try to recreate this query at the controller level and see if the UI still works. So I will do return mediator.send because we expect a response. New forecast query. Everything in MediatR is asynchronous, so we have to wait on it. And if we're waiting on something, then the method has to be a synchronous task. So if we've done everything correctly, the breakpoint is going to hit here, and it's going to hit the query handler. Going to fetch data. We have our breakpoint hitting the controller, so that's still good. And we go into our query handler. That's also good. Our UI still works for now. So now I want UI to dispatch this query as opposed to hitting the HTTP point itself directly. Currently that is happening on our fetch data page over here. So forecasts, I don't want to come from HTTP, get from JSON. I want this to come from MediatR, which has to be injected as a dependency. Inject iMediator. We send request a forecast query and wait on the response. There is a small type mismatch. Usually it is preferable to return IEnumerable while we have here an array. So let's update the definition. There is also a warning about inconsistent naming style. Private properties or fields usually have underscores in them, so we take the change. This, of course, is not going to work right away because the client query has no way of interacting with the server's query handler. They live in a completely different spaces. So we have to find a way to encode this and send it over HTTP to the server instead. Now, how can we do this for all queries and commands. Of course, we can create a handler just for the client, and then every time client wants to process command and query, it encodes it and then sends it to the server. But that is the same process for all queries we're ever going to have. So we need to be able to capture all queries and commands and encode them to HTTP. To achieve this, MediatR has a concept of pipeline behavior. We already know that MediatR is capable of creating a request and map that request to its specific request handler. But if we want to do some kind of pre-processing to all commands, we can create a common pipeline that will accept all commands and queries we create, do some kind of processings in the middle, and only then send them out to their handlers. Or in the case of our client, we may not need our handlers at all. We may just get away with having a pipeline alone that sends everything to HTTP, to the server. I'm going to create this fancy pipeline behavior at the client level. We'll call it RPC behavior because that's what we're trying to emulate. And it takes in two generic parameter types for request and response. It has to implement iPipeline behavior from MediatR and be able to also take in any type of request and any type of response. We'll let IDE implement the missing members. And let's put a breakpoint just to see that this works at all. At the moment it still won't, because as before we have to register this behavior with MediatR and with dependency injection container. Now, unlike in server, where dependency injection is configured in the startup class, and it gives us configure service function with a pointer to the service container, on WebAssembly client, we do that in program class under builder services. As before, we're going to add MediatR, and of course we're not giving it every single possible handler there is. We're just going to let it know where to scan for the handlers. So we pick at least a single class where that handler is going to be found. Type of RPC behavior. Type info and assembly. MediatR also has to know how to instantiate this specific RPC behavior. It's going to try to instantiate things based on this interface name. That's how it's going to search in the dependency injection container for anything pipeline related. So we have to let it know that if MediatR wants to do a pipeline behavior class, it actually has to instantiate an RPC behavior class. So with these 2 points, our breakpoint in the page should get hit. And after it gets hit here, we should expect RPC behavior pipeline to pick up the response. There it is. It continues here. Of course, it now crashes because of this exception that is put in by default. So let's implement that. So the purpose of this RPC behavior pipeline is to take in our requests, encode them into JSON to send them over HTTP to the server. That is pretty standard C# code, so nothing too supernatural about that. We create a constructor with a pointer to HTTP client that WebAssembly's dependency injection will give us. For this client, we are making an HTTP message, request message, and we're going to send everything over post, even queries, because we are actually sending or uploading rather, the entire JSON blob, which of course can only be done over post. Let's say that everything is going to get uploaded to a single entry point on a server, call it RPC. Now for content, this is where we're actually going to encode our request. I'm going to be using Newtonsoft JSON to do the encoding and decoding because newly introduced built-in JSON library to ASP.NET, in order to optimize it for performance, some of the features were removed. And those are the features that they absolutely need to have a reliable representation of the original class sent across the wire, so it can be decoded on the other end in the exact same way it was decoded. So not a huge problem. I can still install Newtonsoft, give it to both client, and I know I'm going to need it on the server eventually, so I will install it right now. And I have to configure it a very specific way. Configuration for Newtonsoft is done with JSON serializer settings. A couple of things that could be useful are preserve reference handling. We want to keep everything as objects. Reference loop handling, going to ignore those. Null value handling, we are still going to include them, so we have the full class structure still preserved. And the most important one of all, one that absolutely must not be missed, is type name handling all. This includes the name of a class being encoded as part of JSON. This is absolutely necessary because I will not have an opportunity on the server to specify exactly what type to decode the class to, or JSON to. It's going to happen automatically. So that name, the target type, has to be still included in JSON. By default, that does not happen, so I have to let it know to do that. So using these settings, we can create our JSON string, JSON convert, serialize object. Our object is our request that's coming from the UI, using these settings. From this JSON string, we make a string content for HTTP request. So this is our JSON content, new string content, JSON encoding, use UTF-8 for transmission, and it is type, from HTTP's perspective, application JSON. We put this content in our HTTP message. If we are logged in, then we also include set browser credentials. And now we can send this to HTTP client. That is an asynchronous operation, so we have to wait on it to be sent. Now to read the response, that is another task that also has to be waited on. So we say content read as string async. Keep on passing a constellation token. I wait on that and mark the function as async so it knows to wait on all of these things. And at the end of all of this waiting, we should expect to get our JSON response back. Now that's JSON response from the server, but we need our response type that was given to us by the generic function call. That's defined over in our query definitions or command definitions over here, so that when MediatR sends it, we actually get back that type, not string. So we use the same settings that we encoded the object with to decode the response into our expected type. So we can use the same JSON settings that we encoded the original object with to decode the response that's coming in. I can emphasize that I'm expecting a particular type to come out, so I will use the type parameter from the generic to dictate what object I actually need. That's my response object. And I will convert back and deserialize into that response JSON that came from the server using the same settings. And I can return that object. I would absolutely love to put a breakpoint here and see how well this works, but I cannot because I don't have this set up. But I'm still really curious how well it actually handles the encoding. So I'm going to monitor the network traffic instead, and let's see what it did. We see it actually did go to RPC URL, and it went there with this payload that contains JSON encoding version of our query. We see it actually includes the type of the object being encoded, so that when it gets to the server, it will know exactly what to decode it back into. So that is working pretty well. Now it's time to create this endpoint so the server can actually do something with the request that is coming in. One way is to create a controller just for this endpoint, do the decoding there, throw it to MediatR and send back. But creating a whole controller is probably too much. We can do this as part of application configuration. So back at startup, in endpoints, we can create manually the endpoint that we want. And we want to be able to handle RPC URL. When we do manual endpoint like this, we have access to context variable. And context has everything from dependency injection container to our HTTP request content. Browser's uploaded content comes in as a stream. So we get a stream reader ready. New stream reader, and we point it to context that is given to us by the lambda function from the endpoint handler. Request and the body of the request. Our request JSON that we're expecting can be read asynchronously with read to end. There seems to be a problem creating a breakpoint in this file specifically, so I will dump the content of that variable to console. And here I see the same JSON that I saw earlier in the network traffic show up at this endpoint handler. So that's working so far. We now need to convert it into an actual object to send it to MediatR. I will reuse the same settings as before. These are very good settings. And we already know how to decode things. That is JSON convert deserialize object. Now, as I said, I don't actually know what object type to get out of it. I am hoping that it's going to do the right thing with the type name handling parameter. So I will only do request JSON and let it know how to handle the JSON into an object. So that's going to be our request object. And we have to throw it over to MediatR for further processing. This context pointer that we get from our endpoint handler not only has HTTP request body, it also has access to dependency injection container. So the same way we had the dependency that we need injected to us in a constructor of other classes, and here I get it out of context, request service, .get service, and I want MediatR to come out of there. And now with this MediatR service ready for me to use, I will give it the command object that we have decoded. Get the result into a variable. That's going to be our response object. And IDE is very worried that MediatR is going to be potentially a null pointer exception, and I really don't expect there to be one because I know MediatR is going to come out. So I will assert that this will never happen. I will indeed always have MediatR there. So this is going to be the result of processing the query or a command. So over here we expect, for example, in this case, actual weather forecast enumerable. We're not going to trust this endpoint handler to do the encoding for us, because it'll probably use the built-in JSON encoder. We cannot have that. And so I am going to continue using Newtonsoft and say that the response JSON is JSON convert, serialize object, response object, and settings. Actually, to be even more descriptive, I should probably call this command query response. Just to emphasize that this is not a response that's coming out of HTTP. It is a response that's coming out of MediatR's command and query handling. Because we got two parallel pipelines going on here. We got the MediatR pipeline and we got the HTTP handling pipeline from ASP.NET. And because we are doing the endpoint handling manually, we have to write the content ourselves back into the response stream. That also happens in a context that's given to us. Response, write async, response JSON. So with this context, we get both request coming in, we get dependency injection container, and we got response coming out. In case we need to authorize this request, if there is a login system, I will add require authorization. But I do not have one set up right now, so I'm going to comment it out so it doesn't cause me troubles for now. Try to run the application, and we see that the forecast is working once again. To emphasize that it is indeed using our RPC pipeline, we can delete all of these unnecessary controllers. We no longer need weather forecast controller or anything controller related. We may not even need map controllers. And we don't even need razor pages anymore. Up in services, we can delete controllers with views, and we can delete razor pages services. Clean the imports, and everything should still work. There we go. Our weather forecast indeed works without anything controller or pages related. Purely automated. We create query anywhere in the client, and it semi-magically connects it to the handler on the server. There is one thing that is still missing for a full convenient RPC experience. At the moment, we are a little bit too direct in reading the response from the query. We actually don't know if it completed successfully or not, especially if it is a command without any response. Right, so queries do have some kind of body associated with them, actual array of our forecast, but what if it was a command that does not have a response? How would we know that it completed? And even with queries that do have content, we don't really have a way to tell if anything went wrong when we done executing this. For example, let's say that in our counter page, not only we are going to increment the counter locally, we are going to also send a command to the server to do something. We don't really expect any data back on it, but we would like to know whether it did it successfully or not. Let's say that in our counter page, not only do we want to increment the local counter, we also want to send some command to the server. I would create an increment command. I will implement interface iRequest. I will have no return type because I don't expect any data back at this point. I will inject MediatR and send it my new increment command. And then server, I am going to create a mirroring increment command handler there. It has to implement as a request handler increment command. We don't really have much to do for this thing on a server, so we'll just remove the exception that is not implemented and do some basic console write line that it did happen. Something got incremented. Okay, so that's good enough. And we have no data to return, so we just say unit.task. And if we restart this, when we press this increment button, on the server we can see that some things indeed got incremented. But we do not have a reliable way to know if it actually happened successfully or not. So we don't care about the response data because there is none, it's just a command, but we do care about whether it actually happened. And even similarly in our fetch data, in case this went wrong, we do want to know what the status of it was and maybe a nice error message about what went wrong. It would be really convenient if at the end of sending we could have some Boolean property that would let us know if it was successful or not. And if it wasn't successful, possibly what the details were. Or even if it was successful, maybe we want to log all of our commands and queries. We may need to get a description of what it is the client was trying to do. I think that is pretty reasonable. So let's say that every time we want to send a command as opposed to a query, we will actually expect some kind of command response back. And in this response, we will be interested if it was successful and a description of command, what it is that we were trying to do. I would like these to be required, so the initial reaction is to create a public constructor that forces us to say whether it was successful or not, and to let us know what it is that we were trying to do. So when we go to increment command handler, the idea is to be able to return a new command response and to say, did anything went wrong, true or false, and for description, increment things. But it's a little bit inconvenient. We have to do these annoying little true and false variables, and it's just annoying. What would be convenient instead is to use similar practice the way ASP.NET controllers use, and that is to return these short keywords, OK or problem. So we can do the same thing ourselves here. Let's say that if this incrementing business was successful, we say something like command response dot OK, things went well, and then we say what it is that we tried to do, increment things. And if there was a problem, we could say return command dot response problem and say incrementing things went bad. Right. So let's create these convenient methods, and they are going to be the ones managing the true and false Boolean properties for us. So we're going to hide this constructor, so we can't use this from outside that easily. But because this has to be encoded and decoded by newtons of JSON, I have to mark it as JSON constructor, otherwise it will not have access to these getter-only properties. I will make public static command response function that only takes detail and that returns new command response that has true for its success status and passes in the description. Similarly, for failed response, I will make command response, call it a problem response. Similarly, give it a detail and return new instance of actual response that has false for its status, and I set a description of what happened. Right. So this looks much better. If things went well, we say command response, okay, I did this, and if there was a problem, we do that. Of course, at the moment, Mediator thinks that nothing is going to come out of it, so we are only allowing it to return a unit. So we can make further convention that if we are making a command, instead of implementing a request interface, I'm going to implement some kind of command interface. Okay, these are not good commands. These commands are from Windows systems, and we are on a server that has nothing to do with Windows. So let's make our own interface. I command. And I know that these commands are actually requests that always return back command responses. Command handlers now have to be updated because not only do they handle the command, but they have to give us back the status. So increment command handler is expected to still process increment command, but it now also needs to give back command response. And consequently, function signature not just returns a unit anymore, but gives us back command response here. Most likely we're going to have database connections that we have to wait on, so we'll throw in async for good measures. There we go. Now our return types are correct. We can either have a response that is successful, or if something went wrong, our database connection failed, for example, then we say no, it can't work. Or maybe validation failed and we're just not allowed to do this. So how will our counter react to this? We can await for the sending to complete. Now this has to become an async task function. And when this is done waiting, we can see whether this was a successful command or not, and display some kind of pop-up with a message that says if command failed, display error telling why. But what do we do if a command does require some kind of data back? That is common for creation of new object. So the server could create new user, create new counter, create whatever, and we need to get back the ID of the thing that it created. So let's say that we have another command that does something as basic as generate another GUID. So we'll say new GUID command. I command, and I want to tell that, hey, but when this command is finished, the object that I'm getting back, I'm expecting its ID. At the moment, I cannot do that because I'm only allowed a command response back. But command response doesn't have any data associated with it, only statuses. So how can I do both? Specify a data type returned at the end of the command while keeping the command response. What I can do is overload this interface, create another one with the same name, but also accept a type as its generic parameter. I have to pass this type also to the definition of command response, because now I want command response to be able to not only have success and description, but also give me the data that's associated with a new object, in this case new GUID. So I can overload this the same way. I can say public class command response, and I will accept the type parameter and extend from basic command response because it's still a response. The data is going to go into its private data property, and its type is going to be whatever we pass in from the command. So t data get. We're going to use the same pattern for constructor. Instead of creating it directly in a handler, we're going to use convenient nice shortcuts. But this is private, so we'll not be able to do this on my child inheritor. So I'll change this to protected. Also protected here. Command response with data whether it was successful or not, description with what happened, and to the base class I will only pass the success and description, and locally I will keep the data. Now, same as before, I am going to need these nice shortcuts here, and just duplicate them and add our actual data to them. At the moment it's claiming it cannot access a protected constructor from this location, which on the first glance doesn't make sense. It's right here, but that's because without the type definition here, it thinks I'm trying to get all the way out here. But no, I'm trying to get the one that has a type. So I will make sure it's marked as T there. Now it's working. And for problem, same thing. We accept data of any type, give it there, and emphasize that I'm going to the current scope, command response, not to the parent. Okay, so all of that is now done, and I can now implement request interface that not only is able to give me empty response with statuses, but response with statuses and some data of type T, of any type. So nicely well done. One minor note here is, do I really need this separated into two files? These things are really meant to work together. Now, of course, there is a general practice of every class needing its own file, but this is really the same unit of work, isn't it? And even ASP.NET actually bundles a lot of the same related classes into the same file, so I'm going to do the same. These things are actually doing the same thing at the end of the day. They all belong together. So put that in the same file, import whatever is missing, and this command response can go away. So now when I go to the command interface, I can actually tell exactly what kind of commands I can have, and I can see what is the correspondent response to that command. Much more convenient. I have, of course, not created a handler for our new GUIDs, so let's do that real quick. New GUID command handler. And what do we expect out of this command handler now? Well, it is a request handler, and we are handling new GUID command, and we are expecting back a command response that contains the GUID that we want to create. Let IDE implement our members, and we return command response that contains GUID data type in it. We'll say everything went fine, and GUID.new GUID. For description, we can say new GUID generated. Mark it as async so it doesn't complain too much. And we're having a minor quarrel in the compiler between this function return type and a function definition. Says it cannot convert GUID into command response that doesn't have a GUID. And if we look at the command definitions, we see that indeed we have not actually created a command response OK, specifically OK call, that is designed to work with a type. So at the moment it is going only to this one, and of course that does not return a command response with any data in it the way this function signature expects. So we need to ensure that it actually goes to the correct extension by marking this command response and this command response with a type. So now compiler is happy, there's no more red line, and so when we do command response with a type to OK, it goes to our extension with types. And in counter, if we say await MediatR send new GUID command, when this thing is done waiting, we can expect to get our data back, which is a GUID. We can even dump into console to see what the new GUID looks like. And of course, we still have our success. In fact, we should probably move this into its own variable so we can see what other interesting things it has to tell us. So bringing the console up, I get a very nice error message, because what would good development experience be without a nice long error message? That the constructor cannot be found. And the constructor cannot be found specifically by JSON serializer. And that would be because in a command I did not mark this thing as a JSON constructor. So it had no way to deserialize the return JSON back into our object. Now when we visit the counter page and do some increment, and it still unfortunately fails as before, same problem that the constructor cannot be found. And this time it's because if we actually pay attention to where this JSON constructor attribute for function comes from, it comes from system text JSON. That's the built-in JSON encoder and decoder. That just doesn't work. So we have to make sure that when we import it, we actually do so from Newtonsoft and not from Microsoft. So make sure we pick this one. And enjoy new GUIDs generated to us by the server and given back as a command response. Well done this RPC pipeline, and notice that when I made a new handler and a new command, I never had to create another controller, never had to create another API. This command or this command just worked out of the box once I created these command handlers. No controllers or API endpoints or HTTP URLs to worry about ever again.